Hello everyone. I hope you were in good health and condition with your friends and family in this global pandemic. Baylor has been running as remote learning. So as a part of remote learning, today I'm going to talk about theory lab of 1420, that is pressure. It's from page 219 to 222 page. So in this lab, we have four sections. In the first section of your tutorial book, that is applying Newton's law. So you have done Newton's law in two objects or three objects, a book over a book, and identify and compare the forces. We have to do the same thing for the liquid. Let's consider a bucket, and here it's full of liquid. Let's say water. For our convenient, we are considering three layers, layer 1, 2, 3. So if I zoom this out from this layer 1, layer 2, layer 3, if I draw the free body diagram for layer 1, we can see the two sides of the two sides. Normal force will be given by the wall of this bucket. From the top, as it is in the top of the layer, that means this is atmospheric pressure. That's why I wrote P atom. Then M1z is the mass and Z gravity working downward. N12 is the normal force due to layer 2. We all are known to contact force or Newton sphere. This N12 and N1 is that type of force. So for level 2, same thing. N2, the two normal force applying by these two are. And N21 is the force due to this level 1 or layer 1, N23 due to layer 3, and M2Z working down for level layer 3, N3 are the forces that will be given by the two wall. And bottom, the bottom pressure will given by this. If I consider this the very most level, so the bottom layer of the bucket will give that pressure or force, and N32 will be given by the second layer as a Newton's force pair. So if I want to calculate the forces N12, N23 and N bottom, so N12 M1z plus atmospheric pressure, for N23 M2z plus N21. N21 we know from Newton's pair, N12 is equal to N21, that is negative side. So I can write this totally. Then for bottom side, N bottom, we can see N3G plus N32. So N32 is this expression. If I do this, so this. So according to these three equations, I can see the bottom layer has the most pressure, force, not pressure, sorry, force, then second layer and third layer. Now in the second section, the section is named as pressure and force. We know a formula, that is P equal to F by A, that P is for pressure, F is for force, A is for area. If I consider A as constant, that means F is proportional to F. If the F is, this equation says us that among these, which layer has the most force, that will have the most pressure. Another formula I want to introduce you, I hope you already know this, and P equal to P naught plus rho GS. P naught, P is the pressure, total pressure, P naught is the atmospheric pressure. If you consider a bucket, the P naught is the pressure of the surroundings. And for rho GS, rho is the density, Z is the gravity, H is the height. Remember, you have to measure the height always from the top. So if I consider this as constant P naught, so rho Z P becomes P equal to rho ZH. Rho and Z is also constant. Rho is the density of the liquid and Z is the gravity. So only the function that depends the pressure, total pressure, on height. So let's demonstrate this thing here. Here I have taken a jug of water and it has some pore like this. So according to our theory, if I take this is the top surface, so this point will have less pressure, then this the lowest one will have the highest pressure. So let's demonstrate this thing. If I open this thing, you can see the water is going where. If I open this, sorry, this one, this is very easy to say. For more, I can open this. Yeah, you can see this layer water is pouring more outside than this. If I open the most lower one, you can see more clearly that the bottom one, the water pressure is more. That's why it's going more distance. So according to the formula, our demonstration also showing the same thing. So our force, pressure and force relation, we have seen that if the height h is the most, the pressure will be the most, and it also makes sense with Newton's approach, like with free body diagram. So in the third section, we will discuss about pressure as a function of depth. We have already seen in the demonstration how the pressure affects, how the height affects the pressure. Here I have taken a tank where this is full of water. So A, B, C, D, E. According to our formula, A, if it is in the top of the layer, A will have the atmospheric pressure, B and C in the same height, and D and E is in the same height. So the pressure rank will be D and E will have the most high pressure, and they will be equal because of their height. B and C also in the same height, so they will have also the same pressure, and atmospheric, finally A point will have the atmospheric pressure, and that will be the less point of pressure. If we consider a imaginary layer like this, then in the previous first section we can draw a free body diagram that will also justify this formula. So in the last section, there is pressure in a U-tube. In the U-tube, U-shaped tube, so has 3 points. In the first, this is a U-shaped tube. This is full open. There is nothing, and I have taken 1, 2, 3, 4, 5, 6 points. F is in the top of the layer. A and E is in the same height. C and D are also in the same height. According to this formula, if we say that if you see that F is in the with the contact of the atmosphere, so F will have the atmospheric pressure, and height H is 0 here, because we have to, our reference point is top of the bar. So here H is 0. If I consider H is 0, that means pressure, total pressure will be P naught, or the atmospheric pressure. So F will have the atmospheric pressure, and A and E are in the same height, so the pressure will be similar, same for C and D. So the rank of the pressure is like this. And for F, as I said, there is no height, so P will be equal to, total pressure will be equal to the atmospheric pressure. And now the same U-shaped tube, where I am adding a stopper, but the water level is same. If that happens, nothing will change. That means whatever, as far as we are not changing the height of the water, the pressure will be the same in every point. The difference, the difference of E and D, and the pressure difference of E and D, in both cases they will be same. Everything will be same. F will have the atmospheric pressure. Now let's do a different thing, like same thing, but we are taking some water by a syringe or something like that. Then we are making this empty, but this stopper side or the right side of the tube will have the same height of the water. Now what will happen? Now you can see, if you want to take water out from this side like this, you cannot do this. This layer will go down, and it will make equilibrium. We have to make something like we have to put some pressure otherwise it will come upside. So this pressure and outside the pressure has to be equal, otherwise it will be it will go up and this will go down. So that means the point A is the pressure of point A is equal to the pressure of this vacuum or this side or the atmospheric pressure. Now the question comes, is the pressure of A and E are equal? Yes, they are equal. As long as their height is same, they will have the same pressure. What will happen to F? As we say, F is now in is more upper side of the level. That means F will have less pressure than these 2 points. And other this point C and D, both will have the same pressure. So the pressure rank will be like this. C and D will have the most pressure, and they will be equal. Then is greater than B, then is greater than A, and E will have same pressure and greater than F. So that's all for the tutorial number 8. Hope it will help you to do the homework and also the tutorial. So stay safe and bye.